Hello everyone! Today, I'm going to show you an incredible hack to bring seemingly dead LED bulbs back to life, along with a clever trick for a DIY mini soldering iron. You know how frustrating it is when a perfectly good LED bulb stops working, and you just toss it? I'll screw it into the socket. And as expected, it doesn't light up. It's completely dead. This is a common issue with LED bulbs, and it's what we're going to tackle today. But in just a few minutes, I'm going to fix it and create a handy tool you'll wonder how you lived without. The first step to fixing our faulty bulb is to carefully open its plastic casing. I'm using a utility knife to gently score around the base where the plastic meets the metal. You need to be precise here to avoid damaging the internal components. Once I've scored it thoroughly, the plastic cover should pop right off, revealing the LED circuit board inside. This is where all the magic happens. Now, for our DIY testing tool, I'm going to take a pair of fine point tweezers. I'll wrap them securely with red electrical tape, making sure to cover all the metal parts except for the very tips. This insulates the tweezers, making them safe to handle while also providing a firm grip. This improvised tool will help us pinpoint the exact faulty LED without needing complex equipment. If an LED is burnt out, it creates an open circuit. By touching the terminals of the faulty LED, I complete the circuit, and the remaining LEDs will momentarily light up. With our bulb connected back to the power, I'm now going to use the modified tweezers to carefully touch each individual LED on the circuit board. This tells me exactly which LED is causing the problem. Ah, there it is. I'm marking it with a blue circle so I know which one to remove. Now that I've identified the faulty LED, I'm carefully unscrewing the bulb from the holder. Using my utility knife, I'm going to gently scrape off and remove the marked LED. It's important to be precise here to avoid damaging the surrounding components. The goal is to create a clean surface where the LED used to be, preparing it for the next step of the repair process. To create our DIY soldering iron, I'm taking a standard AA battery and carefully removing its red metal casing using a pair of pliers. This reveals the plastic shell underneath. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Next, I'll use my utility knife to carefully cut and peel back more of the plastic casing to expose the inner carbon rod. This carbon rod is the key component for our DIY soldering iron. With the carbon rod exposed, I'll use my pliers to extract it from the battery. It's important to get a clean, straight rod. I'll then wipe it down with a paper towel to remove any residue. Now I'm inserting the carbon rod into my electric drill. This allows me to easily sharpen it. I'll use a piece of sandpaper to carefully grind the carbon rod into a fine pointed tip. A sharp tip is essential for precise soldering, especially on small LED circuits. It helps concentrate the heat exactly where we need it. Finally, I'll insert this sharpened carbon rod into the empty metallic battery casings we just removed. This will form the body of our soldering iron. To secure the carbon rod inside the casing and make it robust, I'm using a mix of superglue and baking soda. Using a box cutter, I added baking soda to the base of the carbon rod. I'll apply a drop of superglue around the base of the carbon rod where it meets the casing, then immediately sprinkle baking soda on it. This creates a strong, hard bond that will withstand the heat. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. Now for the electrical connection. I'm taking a small brass connector from an old electrical component and attaching it to the side of our battery casing. Then, I'm screwing in 2 small brass screws into the casing, which will act as terminals for our electrical connections. Next, I'll prepare our connecting wires. I'll strip a small section from one end and carefully wrap it around the screw on our soldering iron handle. I used pliers to tighten the joint, ensuring there was no interruption in the soldering process. To be safe, I used red electrical tape to secure the wire to the battery case. Then I'll strip the other end of the red wire and attach an alligator clip, securing it tightly with pliers. I'll do the same with a white insulated wire, attaching another alligator clip to its end and covering it with blue electrical tape. This setup allows us to create a rapid heat source for quick soldering jobs, perfect for small electronics repairs when a conventional soldering iron isn't available. Now for the setup. I'm connecting the white wire's alligator clip to the negative terminal of a battery. The red wire's clip goes to the positive terminal. I'll place a small wooden block on my workspace. This provides a stable and safe surface for our soldering test. Look at the reaction when touching the carbon rod with the alligator clip. The carbon rod flashed immediately, proving the instant welding ability of the DIY welder. The blade will serve as our test piece. I used the blue alligator clip from the negative end connected to the solder. As I brought the carbon tip into contact with the solder, you can see it heat up quickly and the solder starts to melt and smoke. This confirmed our homemade soldering iron was working perfectly, ready for repair. From the solder, I soldered it to the blade of the utility knife. Here's the result of our test. The utility knife blade now has a neatly soldered spot, showing how effective our DIY tool is. The carbon tip provided enough heat to melt the solder beautifully. Now, let's apply this technique to our LED bulb. Back to our faulty LED bulb. I'm connecting it to this blue plug adapter. This plug will be the holder for my light bulb. Now, using our DIY soldering iron, I'm going to carefully apply a small amount of solder to the area where we removed the burnt LED. I'm short-circuiting the defunct LED, allowing current to flow to the other working LEDs. This essentially creates a bypass, completing the circuit once again. Now for the moment of truth. I'm carefully screwing the repaired bulb into the lamp holder. And there it is, bright and fully functional. It's amazing what a little ingenuity can accomplish with everyday items. So there you have it, a simple yet effective way to repair a faulty LED bulb and even create your own soldering iron from scratch. If you enjoyed this project, please give this video a big thumbs up, share it with your friends, and leave a comment below to let me know what you think. Don't forget to subscribe for more amazing DIY hacks and turn on the notification bell so you never miss an upload. Thanks for watching, and I'll see you in the next one.